And in this project in particular, we're looking at DGTs. And so it is also to provide that robust database of both dissolved and labile metal concentrations in these transitional and coastal waters to allow us to develop adapted environmental quality standards so that we can evaluate the metals in water using DGTs. So just to briefly bring everybody back to what I'm sure you know already, which is that under the WFD, the Water Framework Directive, the aim is to achieve good ecological and chemical status. And I apologize, I think somebody is maybe not on mute. But if then, so the aim is to get the EQS, the environmental quality standard, so that we can be able to assess the waters in terms of metals in particular. And EQS are defined as the concentration of the chemical below which there's not expected to be an adverse effect on the endpoint being considered. And so EQSs for metals in particular refer to the dissolved concentration obtained after filtration through the 0.45 micron filter, and as far as possible for lead and nickel to the bioavailable concentrations. This is particularly challenging for metals because metals are found naturally in the aquatic environment, but then are also considered, certain metals are also considered to pose environmental hazard, but also their toxicity isn't fixed. Instead, their toxicity depends on their speciation, so the chemical form in which the metal exists, as well as environmental parameters like pH, DOC, and so concentrations of total metals in water are understood to have a limited relevance in terms of evaluating their potential environmental risk. In MONITOOL in particular, we're interested in looking at environment or transitional and coastal waters because that adds an additional complication because freshwater and saltwater systems provide very different environments for metal ions, and that can significantly impact their bioavailability as well. And once we move to transitional, so estuarine waters, which are intermediate in salinity and can vary on a diurnal cycle, then there's even more considerations for us. And all of this then considered all this in the context of the EQS, where the adverse effect on the endpoint being considered is where it is going to be measured. There's a specific space then for us to consider DGTs in that space. And the next presentation after mine with Natalia and How is going to be exploring that in more detail. But given how DGTs are already used in investigative monitoring, can help us to identify the EQS in a fashion which is more accurate to determine what their toxicity endpoints are. One of the main aims that we wanted to do in MONITOOL was to see if we could elucidate a relationship between the data obtained on DGTs and current EQSs so that we could then move to be able to use DGTs for regulatory monitoring. And that's what throughout this morning, we are going to show you how we have carried out that as part of MONITOOL. And just to bring back, but I know again, Natalia is going to talk around this too, that within the provisions for WFD, that it is acknowledged that it is desirable to introduce complementary techniques, provided they meet the requirements. So MONITOOL is specifically addressing this request for us within the Water Framework Directive. So to briefly tell you about the project then, we have full partners from the Canary Islands the whole way up to the Scottish Highlands, and also with UNICA in the Mediterranean. We also have a number of associated partners to make sure that the research that we do is relevant to end users and to our key stakeholders. And this is what our project looks like. Everything that's in green, somebody else is going to talk to you around this morning, so I don't need to spend too much time on it. But essentially, across all the partners, we carried out two sampling campaigns, a wet season and a dry season. We have developed common preparation protocols that T is going to talk you through this morning. We used the same batch of DGTs, and then we deployed the DGTs and carried out spot samples. And then across our partnership, our collaboration, IFRMR analyzed the DGTs, IPMA, the spot samples for total metal, IST, the spot samples for labile metals, and then Ifremer and ASTI led the statistical analysis to develop the DGTs. Across all of that too, we carried out a ring study, an interlaboratory study, to develop and validate an expert lab network. And I think Florence is going to tell us around that. So everything here, this is just the introduction and the welcome, and everything we will hear in more detail as the morning progresses. So briefly, we had 8 European regions with 4 sampling sites per region, and we carried out both sampling campaigns in 2018. So we have, in the coast, we carried out 3 days of sampling, 1 sampling per day, and in the estuary, 5 days with 2 samplings at high and at low tide. These are the areas where we carried out our sampling. And in total, we had 21 coastal sites, 13 estuarine sites, and we've analysed over 250 DGTs and over 500 seawater samples from across the campaign. So you can see everybody here actually carrying out the sampling for us. In addition to deploying the DGTs, we did carry out a number of in situ analysis at DGT depth. So we recorded temperature, salinity, dissolved oxygen, pH, turbidity, depth, conductivity, and analyzed biofouling. And Germán is going to talk to us later this morning around the results of those analyses with respect to the metal concentrations that we had recorded. This is an example of the type of analysis that we were able to carry out. So you could see we were able to detect total metals, the DGT concentrations, the individual voltammetry results, and this is what formed the basis of the database that we used for the analysis that Ifremer are going to talk to us around later this morning. So this is everybody in the MONITOOL team. Hopefully we will get to meet you as the morning progresses, but we are so excited to finally have the opportunity, not in person as we had hoped, but as close as we could manage it here, to be able to share everything that we've done together for over the last 3 years with you. So thank you very much.
Thank you very much, Manette, for this great introduction to the project. I think we've got time for 1 or 2 questions, if there are any, and I can't see any hands, or there was nothing in the chat. So I'm just going to look around. And no, yeah, so there isn't any question at this point. So we'll move on into our next presentation, which will be given by Dr. Natalia Montero from the University of Cagliari and Professor Hao Zhang from Lancaster University. And it's relating to why we should consider passive samplers.
Thank you very much, Philip. I'm going to share my screen. Okay.
Lorna, do you want to record these sessions?
It should be set to record at the moment.
Oh, it is recording. Yeah, sorry. Yeah.
Okay, now. I don't know why it's not working.
Oh, okay.
All right, nice, thanks.
Okay.
That's perfect.
Can see that.
Okay, so thank you very much, Philippe, for the introduction. And I will be presenting this presentation entitled Why Passive Samplers on behalf of the University of Cagliari and also Professor Hao Zhang from the University of Lancaster, who is part of the scientific advisory board of the project. So here in this figure, you can see what is the complexity of the problem of contamination, because there are different point and non-point sources. Like they will introduce chemicals to waterways, like for example, urban and stormwater runoff, hospital and industrial effluents, landfills, agriculture and aquaculture activities, and of course also the effluents from wastewater treatment plants. And all these chemicals, they will be transported from rivers to estuaries and finally to the sea. And this gives us a magnitude of this problem. These chemicals, they are divided in different groups, like metals, nutrients, polar compounds, like pharmaceuticals or pesticides, and non-polar compounds, such as PHs, PCBs, flame retardants, and so on. The most important directives dealing with the contamination of aquatic systems in Europe are the Water Framework Directive and the Marine Strategy Framework Directive. And as Blanet explained before, the Water Framework Directive provides a list of priority substances that all member states are enforced to monitor, and then measure concentrations have to be compared to environmental quality standards, and this is used to establish the chemical status of water bodies. However, we have to highlight that in each revision of this directive, new substances can be included in this list of priority substances, and this increased the complexity for member states to follow up with the requirements of the directive. This is especially true since 2015, that it was published the first watch list, and this provides a list of compounds, a group of compounds that they have to be monitored in all member states, but also they provide some acceptable or maximum acceptable detection limits of these analytical techniques that in some cases they are very low, and it's difficult to be measured by traditional sampling and analytical techniques. So when we are talking about the monitoring of contaminants in the water systems, usually this is based on the collection of water samples. This has been done, can be done in different ways. The most traditionally used one is spot sampling, where you go to the field with a bottle, you take a water sample, then you carry it to the lab and you perform the analysis. But of course, you can also use auto samplers, that in this case, you carry the sampler to the field, and ex situ, you collect periodically different water samples, and then you get an integrated water sample, but that is carried to the lab for the analysis. And the most advanced way is the continuous high frequency auto sampler, where the analysis is directly performed in the field. However, this approach has different disadvantages. For example, when you go there and you get a bucket, the information you are getting is very simple because it only represents contaminant concentrations at the exact sampling time. So you are not integrating the different fluctuations of that contaminant in the water volume. And of course, you don't know what happened 5 minutes before the sampling or afterwards. This could be avoided using autosampler, as we observed in the past slide, but this is very expensive. And also these instruments, they need energy. So this limits the number of stations and also the locations. Additionally, when you are analyzing the contaminant concentrations in water samples, usually you have to perform some pre-treatments before the analysis, like for example, filtration in the case of metals, or pre-concentration or extraction. And in these steps, there is a high chance of getting sample contamination or losing some analytes. And also when you are doing extraction, usually involves high volumes of solvents that they are very costly, and also they can cause environmental harm. But especially the most important issue is that to understand what is the relevance of the information you are getting. For example, let's say that we go there to the field and we get chemical concentrations that are below the limit of detection. That doesn't mean that the contaminant is not present. And we also know that some contaminants, they can be really toxic, even at very low concentrations. And also we are not considering some addition or synergistic interactions among chemicals that they can increase the toxicity of a single contaminant. Also, the concentrations that we are measuring, like dissolved or total concentrations, that are the ones we have to report following the European directives. These ones, they are not based on speciation. So it is very difficult to establish what is the potential toxicity of the concentrations we are reporting. But before, in this project, in MONITOOL, we are recommending the use of passive samplers. But before doing it so, we have to understand that at European level, there are hundreds of chemicals that are under scrutiny, and that as science advances, new compounds are going to be considered of concern. Therefore, we need reliable and validated techniques that can be used and can be applied to target these compounds. In this sense, the common implementation strategy of the Water Framework Directive already suggested that passive sampling could be used as a complementary method for improving the quality of the assessment. Afterwards, in 2013, the directive dealing with the priority substances also highlighted that novel monitoring methods such as passive sampling show promise for future applications and that their developments will be pursued. And then, even if passive sampling is not included in the watch list, it is highlighted that the analytical methods used to measure these compounds should not entail excessive cost, and also that if new information arises, probably these acceptable or maximum acceptable detection limits, they will be lower. So probably the traditional sampling and analytical techniques could not comply with the necessities of this list. So in the case of passive samplers, and that's why we are suggesting them, they are relatively cheap, or at least cheaper than if you would like to get the same quality and quantity of information with another kind of technique. And thus they can be applied at many sites, and you can measure many substances at the same time. And also they have the capacity of integrating these fluctuations taking place in that water body. Passive samplers, Blanet already introduced them a bit. They are devices that they are deployed in the field, and they accumulate contaminants continuously during the deployment time. So at the end, you are getting a concentration, the time integrated concentration that represents the whole deployment period. Also, because this accumulation is based on a speciation, the concentrations that are measured represent the potentially bioavailable fraction, and therefore it is easier to establish cause-effect relationships with toxicity. And because they have this pre-concentration capacity, so you don't have to carry high volumes of water to the lab and pre-concentrate them there. They could be used also as early warning signal of contamination. So therefore, passive samplers can supplement, improve, or in some cases even substitute traditional monitoring. In this slide, I'm not going to go into detail, but you can see that there are several types of passive samplers. These are the most commonly used ones for organic compounds, both polar and non-polar. For example, this is the SPMD that it was developed in the 90s. And on your right, you can see a typical deployment canister we use for the field, where you can see the pouches and, in this case, silicone rubber. However, as MONITOOL project is focusing on the use of DGTs, I will talk more in detail about this kind of passive sampler. DGTs stand for diffusive gradients in thin films, and at the beginning they were developed for nutrients and metals, but in the last years they have also developed new resins that they could also measure polar organic compounds. Here on your right, you can see the deployment we performed in the framework of the MONITOOL project, where DGTs, they were placed in a plexiglass holder, and then they were covered by a net to avoid abrasion, avoid that they were deteriorated due to fish. And here you see a common deployment method where we deploy in parallel both passive samplers for metals on the top of the figure, and then the canister, in this case with pouches and silicone rubber for organic compounds. And this is a DGT. A DGT, it's a plastic piston, a Teflon piston, sorry, that is, it has an exposition window of 2 centimeters of diameter that is in contact with the water. And then inside it has 3 membranes: a filter to avoid abrasion, a diffusive gel that it will control the diffusion of these metals that finally they will accumulate on the resin gel. We use different resins that they have a special affinity towards the compound that we want to measure. So that's why we ensure that there is always a positive gradient from the water to inside the DGT, and metals will be collated, in this case metals for MONITOOL will be collated in this high affinity resin. Then this resin is peeled off in the laboratory. We extract it with nitric acid in the case of metals. And then with these easy equations that you can see on your top on the right, we calculate the time integrated concentrations in the water during the deployment time. So as I said, in this case, we have used the KLS 100 type binding resin because we wanted to focus on metals. But nowadays, there are more or less 55 different binding layers that they are used for measuring metals, but also rare earth elements, oxyanions, pharmaceutical, PFAS, and so on. So I'm going to stop it here and let to the rest of the colleagues to go more in depth talking about the passive samplers used in the MONITOOL project. Thank you very much to everybody for your attention.
Thank you, Natalia, for a great summary of different types of passive samplers and how to use them. We're slightly behind our our schedule, so if there's no questions in the chat, and if anybody has any questions, they can go directly to Natalia. So we'll move straight on to the next presentation from Dr. Maria Jesus Belzonce Segara from MASPI in Spain, and she'll be talking about costs and benefits of passive samplers.
No tiene sonido ahora, María. Ahora.
Hello?
¿Más alto? Sí.
You can hear me?
I can hear you. Thank you, Maria.
Yeah. Okay, I'm going to share my screen. Vamos a ver esto. Aquí. Pantalla, ¿no? Pantalla. Esto. Yo tengo que la pantalla, ¿no? Aquí.
Okay, we can see that, Maria.
No se me pone esto. No, abajo
Just go full screen now, Maria. So down the bottom, the little, yeah, that's it.
Un poquito nervioso. So do you hear me and do you see my screen?
Yes. Yes.
Okay, so hello everybody. Well, I have the pleasure to present an estimation of cost in basis of the benefits of passive sampling. This is the content of the presentation with a brief review, very brief, of passive sampling advantages, and to illustrate the field and laboratory steps for both some techniques and estimation of cost into scenarios of cases. So regarding advantages, already Natalia have explained, so I just pass very quick over here. One very important one, that passive sample gives us the time integrated concentration. This is concentration in this figure and sampling time. So for passive sampler, the concentration is this line. And for graph sampling, spot sampling, so we have concentration in a specific moment of the sampling, but we don't know what happens later or before the sampling. So we can over subestimate the concentration. So for passive sampling, it's like a sponge that we put in the waters and can absorb all the variability, the spatial and temporal variability of the system. So the representativeness of the passive sampling is much more than compared with the graph sampling. Also very important, already Natalia mentioned that the contaminant we have is the level concentration, which is related with bioavailability and toxicity effects. So it's more relevant from the point of view of the toxicology and ecology. So it's like the passive sampling is equivalent to sampling in situ hundreds of liters of water during days or weeks. It's like to make the extraction and concentration in situ. What we must do in lab, we can do in situ with the passive sampling. So we are saving a lot of resources and volume of water. For the steps in the lab and in the field for spot sampling, we get the dissolved concentration of the contaminant. We need ultra clean techniques in the field and in the lab, and all the steps that already Natalia has mentioned, some of them, all those steps that we do in the field and in the lab, we can do in once with passive sample. It's like passive sample is a field technique that allows us to extract and concentrate in situ a wide range of contaminants in very simple way. It's like what we have to do in the field and in the lab with the graph sample, we can do in one step by passive sampling. So it means that we have, with passive samples, we have very simple techniques, robust, easy to manipulate. We need less manipulation of samples, are efficient techniques and cheap. So because of all of that, we save money with these techniques. It's like passive sampling, passive sampler techniques are like off-road techniques because we can go everywhere with them. There are little devices that we can put in the boxes, easy to transport, easy to deploy in everywhere, easy to handle, no manipulation or less manipulation, efficient, cheap. Again, because of that, we save money. So this is to illustrate very quick the steps we do in the lab with when we have recovered the passive samples from the field. In this case, with DGT, because DGT is the passive sample that we use in MONITOOL. So the DGTs we can deploy in the field just with a fish line or with in an extractor, a plastic extractor. After recovering from the field, we have to put immediately in a clean, perfect clean bags, plastic bags after cleaning, and transport to the lab in a very they're small and you need boxes, small boxes, also clean boxes. And once in the lab, we take off from the structure, from the plastic bag, and just we open the DGT and take off the resin, and the resin put in vials, little volume of nitric acid for the metal extraction from the resin. And after 24 hours, we take out the resin and we close the vials and are just prepared for analysis. It's just very simple. So for the estimation, a very estimation of costs. In the case that we need to do, in case one that we need to study a specific problem in an estuary a contamination problem with metals. We need to study during 10 days this problem. So we can use passive sampling, or we can use spot sampling. What are the difference in cost and resources? So in the field work, we need just today for sampling, 1 day for DGT deployment, and 1 day after 10 days deployment, we go again for DGT retrieval. In the case of spot sampling, for the 10 days study, we need to go every day to the field to take a water sample, and we need to take 2 times per day, a low and high tide, because we said that we are in an estuary that is very variable system. So we need to go for 20 sampling times. Regarding material, at least we need 3 DGTs to deploy and 1 DGT for field blank, and later at the lab we need 3 DGTs like for lab blanks. In the case of the spot sampling, we need a Niskin bottle, a specific one for trace metal studies, Teflon recover, and 20 sampling bottles, 1 liter. We need to manipulate 20 liters of water. Price. The price of the DGTs we need are from 6 euros or less to 13 euros, depending on the demanding of DGTs and the number of DGT users. So the price can range from 42 euros to 91 euros. In the case of the spot sampling, we need the Niskin bottle that normally in marine lab you have a Niskin bottle already bought that costs around 1,500 euros, plus the plastic bottles are around 55 euros. Regarding the laboratory work, since you open the DGTs and are prepared, ready to analyze, you need just 2 hours work, more or less. For the spot sampling, for the samples that you get with the spot sampling, you have 20 liters of water to filtrate and do the other steps to get it ready for analysis. You need, depending on the condition of the laboratory, you need 2 or 3 days work. So for this case, for operative and investigative monitoring, it's clear that with passive sampling, we save time, personnel, material, and transport to get the same quality of data with passive sampling or with the spot sampling. So passive sampling is more cheaper in that case. In the second case, well, you don't see the title. Yeah, you can see. In the second case, if you need to do surveillance monitoring during 1 year, it means that you have to go in an estuary. You have to detect metal contamination. So you go to the field once a month. Every month you go. So with passive sampling, you need to go every month 2 times. One for the digital deployment, and one after. You can live there for 10 days, 2 weeks. You will have a good quality of data, but you have to go another time in the month to retrieve the DGT. So you need 24 sampling days. For spot sampling, just you go once a month, so 12 sampling days in total in 1 year. So it's much, in this case, for spot sampling, we save resources, staff, personnel, transport, etc. What about material? Material, at least you need 3 DGTs, 1 DGT field blank for 12 months. And for spot sampling, the Niskin bottle that you already have, and 12 sampling bottles, you need 12 liters of water. The price, again, it depends on the production and on the demanding of DGTs, can range from 6 euros or even less to 13 euros. So the price will be 300 euros to 663 euros. For the spot sampling, you have the Niskin bottle already that costs you 1,500 and about 25 euros the plastic bottles. For the laboratory work, if you all the digits that you recover from the field, you can keep in the fridge and process all together at the end of the whole study, and you need just 1 day work for all of them. For the 12 liter of water, you can keep frozen, and at the end of the study, yes, you need to filter and extraction, concentration, and all the steps until you get ready for analysis can take you 1.5 days or 2 days, depending on the laboratory conditions. So in this case, with passive sampling, we need double of sampling days, more personnel, more transport, but less work in the laboratory, less sample manipulation, less additional contamination. We gain in data quality. So we have to consider really the objective of our study. If we want to have the equivalent quality of data, if with passive sampling, we gain in that. So conclusion. With the spot sampling, again, you can overestimate concentration. It's not very representative, no speciation information, no ecotoxicological relevance. But with passive sample, all these limitations you can overcome using passive sample, and many times with much lower costs, cost on time, on resources, on personnel, and it's a guarantee that you have a good quality of data. So this is all. Thank you very much. Hello.
Thank you very much, Maria. I think it's the first time I've seen such a detailed cost-benefit analysis. We're still slightly behind, so I'm going to, there's a couple of questions in the chat, by the way, that's relating to the protocol. So, which is the next presentation, really, a little bit more detail on protocols for spot sampling and concurrent DGT sampling. And that presentation will be given by T. Bolam from CFAS.
Thanks very much, Philip. Yes, for these presentations, I actually pre-recorded the presentations, which I'm going to upload and play it for you. So hopefully it is working. Can you see the screen at the moment?
Not yet.
Okay.
That's it now, we can see the screen.
Okay, I will try to play it. Hopefully you can hear it properly. If not, do let me know. Thanks.
I don't think there's any sound, or maybe
there's no sound yet, so you'll have to stop sharing, and then you have to go to share screen again, and then you have to go to advanced options to share sound. It's a problem that always happens on Zoom as well. So let's.
Okay, I think what I do, I'm just going to try upload my presentations and just do it to a live one. That's a bit easier, I think. So bear with me a minute.
No problem. And we can see it now, so that's
Okay,
perfect.
that's great. So yes, this presentation is about the protocols and the field sampling, analytical methods that all partners followed in the presentations in the preparations of the sampling survey to the undertaking of the sampling campaigns and subsequent analysis. Within the monitoring project, there are 8 partners taking part in the sampling campaigns in their respective areas, as well as carrying out a numbers of analysis. So we need to have so one of the objectives of the work package 5 is to have a common strategy for the sampling and sampling processing and analysis. This is to avoid operational variabilities in the field and in the lab works. So the data, this is to ensure the comparability and the reproducibility of the data, which is going to be used later on for correlation studies under the work package 4 and for the EQS adaptations under work package 6. So the main focus of this presentation will be on the concurrent spot sampling and DGT deployment, specifically looking at, in the first instance, the pre-survey sampling preparations in terms of reagent, materials, and equipment for the spot sampling and the DGT deployment. And secondly, to go through the details of the sampling survey itself, for example, how we selected the sampling site, how often we collected samples, and how the spot water samples and the DGT were dealt with during the survey and after the sampling campaign. So in terms of reagents, materials, and equipment, for the spot water sampling, we mainly use the wide neck 500 ml HDP bottles, and for the filtrations process, we use these little equipment called DG tubes and the DG filters. Both bottles and filters have gone through a cleaning cycle with 10% nitric acid and then rinsed with deionized water before use. For the purpose of the monitoring project, in order to further minimize the operational variability, we all procured the DG filters and the DG tubes from the same supplier. And for the DGT deployment, we use the commercially available DGT from the DGT Research Limited, which is the loaded DGT device you can see here, with a Kellex binding layer. Again, for the monitoring project, we ensure that all the DGT used for each sampling campaign are procured from the same production batch to minimize the variability. So these DGTs were assembled in a clean laboratory environment, preferably under a laminar flow cabinet or in a clean plastic bags to avoid contaminations from air exposures. And these DGTs are loaded onto a DGT holder in triplicate, and again wrapped around with a net to avoid damage to the DGTs from the side impact. And these assemblies are then stored in a fridge prior use or in a cooler box during a transportation. When we are mounting this DGT, we also expose the field blank DGT, which is on. We just expose them onto a clean surface while the triplicate DGTs were mounted onto those holder. These field blank are then placed back in the plastic bags and stored refrigerated until the deployment day. During the manipulations of the DGTs, we of course use the non-powder gloves when we're handling them, just to avoid further cross-contamination. So when it comes to the sampling site, the sampling site features and characteristics must be considered for the selections of those sites. For example, we need to choose a suitable sampling depth or take into account the level of pollution for each site. We also need to ensure that the sampling site is suitable for DGT deployment. For example, having a designated deployment structure, use of the mooring, use of the moorings or the buoys, or a fixed structure where the DGT assembly can be attached via rope with a weight at the end of the rope. The other options is to place the DGT assembly between a weight resting at the bottom and a buoy on the top in order to keep the DGT at the desired height. We also need to think about the ease of access of the sampling site, the safe access of the sampling site, just to be, for example, away from the public interference as much as possible. In terms of sampling frequency, we had a mixture of tidal estuarine site and transitional and coastal sites during our MONITOOL project. At tidal estuarine sites, we took the sampling twice a day at high and low tide for each day of the DGT deployment. In other transitional waters on coastal side, the sampling was done once a day. Sorry. So when it comes to spots water sampling, the MONITOOL project collected the discrete spot water samples in transitional estuarine and coastal waters for the measurements of the concentrations of the EU Water Framework Directive practice metals, which is lead, nickel, and cadmium, as well as aluminium, cobalt, copper, iron, manganese, and zinc. The water samples are collected at the same depth as for the immersion depth of the DGTs, and ideally direct sampling into pre-cleaned bottles should be done as best practice, and wearing non-powdered gloves. So for this activity, numbers of water sampling devices were used during the MONITOOL sampling campaigns. These include grab samplers or Niskin bottles, a handheld water sample, or remote automatic sampler. The water samples were collected for trace analysis by volumetry, ICP-MS, or for the determinations of dissolved oxygen, suspended particulate matter, dissolved organic carbon, and turbidity. So as laid out in the objective of work package 5, we have dedicated partners in charge of specific type of samples preparations or analysis. For example, CFAS was in charge of the filtrations for all the water collected. This is intended for volumetry. Our partner ISD were mainly in charge of the analysis of the filtrate water by volumetry, and our colleagues from IPMA solely carries out the trace metal analysis for all the water samples by ICP-MS. So as I mentioned previously, all the DGT's devices are preloaded onto a DGT holder and protected with a net if needed, and they are transported to the sampling site in the cooler box to keep it refrigerated. So the DGTs are deployed ideally at a depth of 1 to 1.5 meters from the surface, and at least 1 meter above the seabed, either attached to a solid structure or onto a buoy. And again, while manipulating the filled DGT before the deployment, we also expose the fill blanked DGT at the same time on the clean surface until the DGT holders is submerged into the water. Once this is done, we put all the DGT fill blank back into the original plastic, and then store refrigerated until the retrieval time. As soon as this is deployed, we need to record the date, the time, and the temperatures of the water during the deployment time, sorry. For the sample duration, the optimum deployment time depends on these dissolved metal concentrations in water and quantification limits of the analytical technique. The deployment times between 3 to 21 days might be appropriate if the site-specific characteristics do not favor any significant biofouling development on the DGT sampling surface. If the metal concentrations is expected to be very low, for example, in an offshore marine environment, and there is no indications of biofilm growth onto the surface on the DGT, then longer deployment times might be appropriate. For the MONITOOL project, our sampling campaigns fix the DGT deployment times to around 4 days. When it comes to retrieval time, we proceed as we did for deployment times, as in we expose our field blank DGT onto the clean surface when we're retrieving the DGT. Once everything is out of the water, we put those field blank back into the plastic bags and keep everything refrigerated in the cooler box. And again, we need to record the day, the time, and the temperature of the when we retrieve those DGTs from the water. And these DGTs are then transported back to the lab, where we can send to our partner Ifremer for analysis. So just very briefly, as well as the field sampling protocol, we also produce this sampling processing analysis protocol, which is a series of methodologies to ensure the comparability and reproducibility of the data obtained from each partner, and that the protocols that all our partners follow. So the protocol describes the methodologies for sea water filtrations using DG filters, DG tubes, determinations of trace metals in seawater by ICP-MS and by volumetry, and determinations of trace metals DGT by ICP-MS, and also determinations of various physical parameters like suspended particulate matters, dissolved oxygen stability, and dissolved organic carbon. So as I previously mentioned, the main sample preparations analysis, which is the top 4 here, are carried out by a single lab partner to avoid operational variability in the lab work. And the rest is followed by our partners to minimize as much variability as possible. And finally, I just wanted to mention a few outputs associated to these protocols as a result. The first one being a paper that we are currently submitted. It is on the concurrent sampling of transitional and coastal water by diffusive gradient in thin films and spot sampling for trace metal analysis. So this is now been submitted to the Method X publications, and we are awaiting reviewers' feedback. So this paper has been led by CFAS with all the input from all our partners. The second output is the good practice guide for the use of DGTs, sampling of metals in transitional and coastal waters by DGT technique. So this is a guide. This guide is the combinations of the paper above and our MONITOOL protocols. It is a little bit less scientific and more didactic, and probably more accessible for all parties of interest. So this guide has been led by our ITC partner with everyone's contributions. And again, once this is done, this is going to be available on the MONITOOL website. And lastly, there are 5 MONITOOL videos that were produced by our IFREMER colleague to support the sampling protocol. The first one being the MONITOOL field sampling, demonstrations with Jean-Louis Gonzalez. And we also have 4 tutorials on the use of DGC. And these all 5 videos are published on the MONITOOL website. So yes, that's all I would like to say about the MONITOOL protocols, and thank you very much for listening. If you have any questions, please, yeah, just send us any questions you might have, and we can get back to you.
Thank you very much, Dee. There's a few questions in the chat and we're trying to answer them as we go along, but in view of the time, I would just like to thank all the presenters this morning that have provided the scene for the next session. And one thing I'd like to say is that we're very anxious to hear the voices of the stakeholder and end users. So we've got we've got 3 breakout sessions later on this afternoon that will allow discussions and sharing opinions. So we're going to go into a break now of 10 minutes. So coming back at about 10 past 11, Blaned is going to take over chairing the next session, and I believe I'm left to thank everybody that's contributed this morning. Okay, we'll see you in 10 minutes. Thank you.
do. And to be honest, David, that's a question I don't know. It's not my area, unfortunately, David, so I don't know. I don't know what they've done in the past.
Good morning, everybody, and welcome to the next session. In this second section here, we are going.
The next plenary session is starting. So if you
Sorry, I had crosstalk there for a second. We're starting the next session now. In this section, we are going to be going through the details. Like Philippe said, we set the scene in the last session, and now we are going to talk through with colleagues around what the outputs from MONITOOL have been. So without any further delay, I will pass over to Florence to hopefully start the next presentation around the results from the interlaboratory study. Thank you, Florence.
Thank you. Can you hear me?
Yes.
Yes. Okay, great. I'm now going to share my screen. And that should be this one. Ooh. Is it?
Yes, we can see that.
Okay, great. So good morning. So my name is Florence Monet. I'm working at IFREMER, and I'm going to present the task that was mostly led by the team IFREMER with Jean-Louis Gonzalez, Stéphane Guédon, Isabelle Lamoureux, and myself about a DGT interlaboratory comparison exercise. So the objectives of this task were to investigate each analytical steps and give recommendations to improve results reliability, and assess the actual DGT analysis capacity within the MONITOOL project partners, since 80% had no experience in analysis of DGTs, and to develop a network of expert laboratories for DGT analysis. So I'm just going to do a small reminder about the DGT processing in laboratory and the different steps that are involved. So the first step is to open the DGTs. So for that, we use a screwdriver that is protected mostly. And once we open the DGT, there is a small schematic here about how the DGTs are made. So you open the cap here, and then you have to remove the 0.45 micrometer filter membrane at first, and then the diffusion gel, and then you get to the resin that you can retrieve. And you put this resin in a tube and add some nitric acid for the elution of the resin and to get the metals to get in solution. And then you can perform the analysis, and mostly the ICP-MS is used for this, this type of analysis. So these are the different steps that were investigated in this inter-laboratory comparison exercise. So how it was designed. So the DGTs were all exposed in marine waters, so in a site at the Mediterranean Sea in the Lazarette Bay, that is here showed here. So they were all exposed there for the same time. And then several samples were given to all the participating laboratories. So we have a sample where the resin was already eluted with the nitric acid for the exposed DGT. So this sample was aimed to evaluate the step of analysis only. Then we had another sample where the resin only was already taken out of the DGT, was given in a tube. So we had to perform the elution with the nitric acid and then the analysis. And then two other samples were given. One was whole exposed DGTs. So they were not opened. We had to perform all the steps, and blanks also, the DGTs blanks that were not exposed to marine water. So for these two, we had all the steps to perform: opening, retrieval, elution, and analysis. So with these samples, the aim was to look at the potential contamination that could occur during the analysis of DGTs, since the contamination risks increase with the number of steps that we have to perform in the laboratory. So all these results were interpreting according to the ISO 13528 guide, so which is used generally for interlaboratory comparison data treatments. And for that, we calculate a Z-score, which gives us the results quality according to the assigned value that was determined. So if we have the results are between 2 and -2, we have satisfactory results. If the Z-scores are between +2 and +3, or -2 or -3, we are in a questionable zone. That means that there is a little problem with the analysis, but the results are still considered as good. And then if it's over 3 or -3 or under -3, then the results are unsatisfactory. So for this exercise, we had 9 participating laboratories that are listed here in this table. And so most of them performed all the different steps of the intercomparison exercise. So more than 127 exposed DGTs were analyzed, and 57 laboratory blanks and 2 acid blanks were also analyzed. So in the following sections presenting the results, all the laboratories will be identified by numbers which are anonymous, so it's not the same order than in this table. So if we look at the results, so we have here for each line here, we have the cadmium results, then the second line is nickel results, and third line is the lead results. And in the first column, you have the results for the analysis only, where we had the resin eluted, already eluted, so we only had the analysis to do. Here in the middle, we had the 2 steps to do, the elution plus the analysis. And in the third step, we had everything to do, opening the DGTs and make the analysis, elution and analysis. And so from left to right, you, in theory, potentially increase the contamination risks. So what these results show us is that we more or less had quite good homogeneity of the results for the eluate analysis. So here the results on the first, the left column, except for lead, which was a little more variable. And then we had a much higher variability of the results for whole DGTs, which means that during the different steps that we had to perform in the lab, there were likely some contamination. And we can still see that some cases you had, like for that lab 3, systematic bias, which is likely due to an analytical problem, and so problem of accuracy of the analysis. And for information, the results are not shown here, but for information, blanks were generally low for all these metals analyzed. And so if we make these results in the Z-score results, what we can see is, so that it's the same organization. You have here cadmium, second line nickel, and third line lead. And on the left, the eluate to analyze. Here, the elution plus analysis, the resin. And here on the right is the whole analysis, the whole DGTs analysis. And so what we can see is that for cadmium here, clearly, well, it seems that the lab 3 had an analytical problem. All these Z-scores are over 3, which means that there is very, very much a problem. And for lab 1 and 7, we can see contamination during the whole analysis of the whole DGTs. So the steps, there was some contamination during, not probably during the opening and retrieval steps. For nickel, we had for lab 7, one time here, slightly questionable results here, which means that there potentially was a one-time contamination at the elution steps. And for lab 2, there was contamination of whole DGTs for the 2 replicates. When you have 2 bars, it means that there were replicates of the samples. And for lead, so we had lab 7 and 8 seems to had contamination problem during the elution steps. The results were more questionable or unsatisfactory for lab 8, whereas the analysis only was relatively quite good for the two of them. And for lab 1, apparently there was contamination for the analysis of the whole DGT, and but especially for one of the 2 replicates that were analyzed for this laboratory. So if we go to the conclusions, what this exercise showed us is that there was quite a success for us, for the organization, since we had quite reproducible concentrations for all the metals analyzed presented here. That DGT analysis is achievable by laboratories measuring metals concentrations in the marine environment, even with no previous experience with DGTs. And so among the 9 participating laboratories, well, I showed only 8 results because one of the laboratory had no valid results due to analytical problems with the choice of the techniques that was used to analyze the DGTs. So over the 8 other laboratories, 100%, 3 of them had 100% satisfactory results. 3 of them had 80% satisfactory results, and 2 of them had 60% satisfactory results. And if we look at the different critical steps, what we see is that the unsatisfactory results are mostly happening when we have the whole processing, the DGT processing, when we have the DGT opening a resin retrieval steps to perform. 30% of these unsatisfactory results occur with the elution and elution steps, so likely one time, maybe one of contamination of the with the nitric acid, and 10% were due to a problem with analysis. So this shows that 60% of the contamination problems occur at the first stage of the process when we open the DGT. So this step has to be really carefully done and under the most cleaned conditions as possible. And what we did with this, all this information is to make recommendations to improve DGT's analysis, and these recommendations will be published in an article and guides that will be produced during the project. And thank you very much for your attention, and for the participating laboratory. We had the DGT, the Diego Golden Trophy that was awarded to the participating laboratories thanks to the project. So thank you very much for your attention.
Thank you very much for the, well, as a recipient of Diego, thank you very much for Diego. He has pride of place in our laboratory. And more broadly, thank you very much for sharing those results with us. I think it is incredibly useful for DGT use going forward to understand exactly where the critical points are for potential contamination, where there might be an issue. So we look forward to the publication from that. We don't have any questions from this one. Natalia has answered the explanation around the reason for using the net. Thank you very much for that, Natalia. So I think we have no more questions. So we will move to the next presentation, which is where Herman from ASTI is going to explore with us the relationship between the DGT spot sampling techniques with the environmental parameters. So I'll pass over to you now. Thank you very much.
Good morning. Can you hear me? I can't share. Okay, my name is Herman Rodriguez for ASTI. I will try to explain in 10 minutes a lot of information, so sorry some parts is not clearly explained, but you can do questions after the presentations. Okay, in fact, there are two presentations. One is focused on the relationship among metals, and in this part of the day, I think that it's time to explain that we are not only comparing metals, but we are always also comparing different fractions of the metals in the water. Okay. In one hand, we are measuring the dissolved metal fraction, and in other hand, we are measuring the labile metal fraction. That they are related, but are not exactly the same. We can define the dissolved fraction as those that we get from the water after filtration, okay? And the in situ labile fraction, and that we get with DGTs that have been exposed to the water, okay? In the next slide, we show the different fractions of the metal present in a water sample, but in a very simplified form, okay? So this is the total metal content in water, and you can use a threshold or a boundary for take out the particular metal, and here we have this fraction. We can say that this is the dissolved fraction, okay? And a part of the dissolved fraction is the labile metal, that fraction that you can measure with DET, okay? Depending of the speciation of the metal, this fraction can be completely different, okay? When we measure with the DGT. So for measuring the dissolved fraction, we have a period of time, and we have a metal concentration in the blue line that is varying in the environment. And we can do a spot sampling, and after filtration, we can measure the total dissolved fraction. That is this part of the metal, okay? And with DGTs, in the same period, we have used, we got exposed in the water, and we can get the labile metal measured content by DGTs. Okay, so we are trying to relate not only to two different methods, that we're trying to compare two different fractions of the metal content. Okay, DGT labile versus total dissolved. Okay. A small note, as my colleague has explained today, spot samples were measured by ICP masses and also by voltammetry, but today we are only to speak about ICP masses, okay? So, in order to relate the one method that I will put the DGT in this axis and the result of filter spot sampling in this part of the graph, we are going to use not a usual relation that is this kind of relation that is Taiwan, that it tries to minimize these red distances. We are going to use this another kind of relation that it tries to minimize this distance, that is the perpendicular one. Okay, so it's a small detail in okay. And regarding to cadmium, this graph in this axis, we are putting the mean value of the different replicates of DGT, okay, and the concentration in nanogram per liter. And in this part is the mean value measured in filtered waters with SCP masses. Okay, we can see that there is a strong relationship between both methods, and it's quite linear. Okay, and in the right part, it's just the same data, but I have applied a logarithm. Okay, so in axis is the logarithm of DGT values. This axis is the logarithm of the dissolved fraction content. Okay, and also there is a strong relationship either in linear way and either in, we say, a log linear way. Okay, for nickel, it's completely different. Okay, in a linear way, we can see that there are a lot of scattering, and then the adjustment is a little worse. But in the case of log data, okay, we say that it adjusts very well to a linear adjustment. Okay. In the case of this, we can see that in a linear way. Remember that here we have the DGT data, and here we have the spot sampling data, and we can see that in the lower values there is almost no relationship or no strong relationship between DGT and between spot sampling. Okay, it's like an horizontal distribution of data. After that, we can see that there is a weak relationship. And in the case of log transform data, it adjusts better to a linear way, but also we have quite scattering or what scattering data between both methods. Okay. In the case of cobalt, it's worse. Very bad adjustment in the case of linear adjustment. Okay, non-transformed data, very bad, very scattered data. And in the case of logarithm, also very scattered data, very scattered relationship. So it's a very poor relationship between both methods. Okay. In the case of copper, it's quite good. Also in the linear way, we have a good adjustment, and also in the log-log linear way, adjustment is quite good. Okay. In the case of manganese, the distribution of data is logarithmic. We have a lot of values of data in low values data and a very few high data. The adjustment in logarithm is quite good, and also the adjustment in log-log relationship is very good. Of course, there are some extreme values, but in general, most of the value adjust very well to align. In the case of zinc, the adjustment is bad. In a linear way, we have a lot of data very scattered, and also in log relationship, we have a poor relationship, a weak relationship. Okay, among different methods. Okay, so the main conclusion is that for cadmium, manganese, and copper, there is a strong and direct log-log relationship. For nickel and lead, we have a medium strength relationship, but for cobalt and for zinc, the relationship is very, very weak. Okay. Okay, this is the first part of the presentation, and I want to explain a very synthesis of a relationship between the physical-chemical parameters and the relationship between both methodologies. Previous research with DGT have found that at local scale, the variability in the ratio of the DGT labile fraction to the total dissolved fraction might depend or can be explained from the characteristics of the environment. Okay? This is logical. For example, in some metals, the dissolved organic carbon in water can explain this ratio because remember that part of the metal can be linked to this carbon. Okay, so we want to do the same research that have been done at local scale, but in a broad geographic scale. Okay, we have explored these variables and also other, but today we are only to speak about this: temperature, salinity, oxygen, pH, suspended particulate matter, dissolved organic carbon, fouling, and also we have compared also if there are differences between coastal sites and estuaries. Okay. The graphs will be all the same. In this part of the graph, I will represent the parameter, for example, temperature, and here we are going to put the DGT spot sampling rate. Okay, the mean concentration measured by DGT to the mean concentration of filtered water measured by spot sampling. Okay, if we get this kind of relationship, we can consider that this parameter is not explaining the relationship between methods. Also, we can get this kind of relationship with a break or with a jump. Also, this kind of relationship or this kind of relationship. So we have explored all the possible combinations among the ratio between methods and all the environmental variables. In the graph, I will show you the ratio log transfer. Okay, it's not the natural ratio. Okay? And in some case, the parameter is log transformed. Okay, this is in this axis. I have the mean value of seawater temperature. Okay, measured in situ, and here we have the logarithm of the DGT spot rate. Okay. Blue dots correspond to coastal areas and red plots correspond to estuaries. Okay, you can say that this is not a clear trend. So we can consider that temperature is not explaining the variability of the DGT spot sampling ratio for leaf. Okay. Again, salinity. This is not a clear pattern. This is a random pattern. And the same with oxygen. This is quite horizontal. It's not a clear pattern. And with pH, it looks that it is indirect relationship, but this is not significant. Okay, statistically significant. And with suspended particulate matter, where this, okay, they are not any pattern. At a direct relationship with dissolved organic compound has been formed at the Daiger dissolved organic carbon Daiger ratio, but this is not statistically significant. Okay. In general, we have not found statistical or clear patterns between the ratio and the physicochemical parameters. There are a few exceptions, a few significant relationships. One is the related to cadmium. Okay, that is an indirect relationship. So the higher the pH value, the lower the ratio. We have also a relationship between the oxygen content and the ratio for nickel, again indirect, and also in the case of zinc with suspended particulate matter. Okay, there is a significant relationship, but in general, this is very scattered relationship. We have to take account that it's just logarithm data. Okay, it's very small change implies a very big change in non-conforming data. So very few are significant, and in general, a very scattered relationship. Okay, well, what about the following? Okay, following is the accumulation of the unbound material on DGT that can infer in the capacity of the DGT for touching metals. Okay, and again, I show here the x-axis the percentage of surface affected by fouling after exposure time. Okay, very low fouling and a lot of fouling, more than 10%. Okay, and again here we have the ratio of DGT for spot ratio. Okay, in the case of cadmium there is not relationship. In the case of nickel there is not relationship, but in the case of copper is a significant relationship. Again, it's very scattered. Okay, for a value of 1%, for example, we have a very wide range. So this relationship is significant. Okay, at very low values of fouling, we have found higher ratio. Okay, in the case of lead, we have very few data and no nuclear pattern have been found. So in the case of manganese, no relationship, and in the case of zinc, there is no relationship with fouling. Okay. And what about coastal sites or estuary? Okay, these are box plots. This bar, central bar, represents the median value of each subset of data. Okay, is the central value of the data. In general, there is no clear difference between coastal area and estuary for each of the metals. Yes, in the case of lead, but we have to take into account that we have very few data for coastal area. And when we do a test to check if there are significant difference in the median values, we have not found significant difference. So I think we consider that to be in coastal area or estuary is not a factor explaining the variability in the ratio. Okay, so the main conclusion is that DGT spot ratio was not explained by temperature, salinity, pH, oxygen, organic content, suspended particulate matter, fouling or estuary coastal, but some of the relationships were statistically significant. Okay? Thank you very much. This is a little of spam for you. The main of the results can be checked in this article.
Thank you very much. That was a really illuminating conversation about the main findings that we had. There's a couple of questions in the chat. Many colleagues answered from MONITOOL have answered many of the questions, but I'll just direct one directly to you, Herman, which was that were the ICP dissolved concentrations an average of the grab samplings or the last dissolved concentration? That was a question from Joseph. Sorry, you're on mute.
Yeah, sorry. Let's see in the chat.
So the question is, was the ICP dissolved concentration an average of the grab samples or the last dissolved concentration?
No, it's an average of all of the grab sample, of the spot sample.
Brilliant, thank you. And then I'll direct the next question to Miguel from, apologies for butchering your name, Merrick, who wondered what the pre-treatments were for the spot samples before ICP-MS analysis.
Well, pre-treatment was done through a CFAST. So it's a chelating system based on Chelex, modified Chelex resin, and that removed most of the alkaline and alkaline elements and concentrated in 8 times the metals in the samples, and this is all done in line with no sample manipulation, so it's quite free from concentrations due to contamination due to manipulation.
Great, thank you very much. And then I'm sorry, there's one question I didn't fully understand from Amore, which was around the effect of a peak of metal concentrations in biota. How can I see the peak when using DGT? If the person who asked this question wanted to put their mic on and ask the question again, perhaps.
May I speak?
Yes, absolutely.
Yes, perhaps Amaury is referring to how do we can find a peak in the concentration if we only have an average. With only one, we cannot. But if you have several DGTs deployed and retrieved at different times, then from there you could extract the moment of a peak. But obviously, from an average, if you only have one average, you don't know when it was up or down.
Okay, yes. So I think that will be one of the things that maybe.
Sorry, so we need some. We need some spot DGT sampling for see the peak. Is it?
So maybe I might. So Isabel is going to give the next presentation for us. So Isabel, do you mind to take that question at the beginning of your presentation?
I think that yes, there is a difference. German spoke about it. There is a difference between the DGT and the spot measurement. So effectively, we measure an average with DGT. The aim is not to detect peak. If you want to detect peak, I think the question is different. It means that you know really how your concentration can vary along the year, and so you can identify the best period in which you can deploy DGT for maybe a short period of time. because the DGT will give you the information, the concentration that you will have in the media during the time of deployment. Is it okay?
Yes, absolutely. Thank you. And I think that is something that we can explore more in an afternoon session when we move to the breakout sessions in any case. I'm aware we're starting to lose time a little bit, so yes. I might invite you to tell us around the EQS adaptation, if that's okay, Isabel.
Yes.
Thank you.
You can see my screen. Okay. Yes. It's okay. Thank you. So I'm going to do a presentation on how to use DGT results for chemical status assessment. I will focus my presentation on EQS adaptation for the 3 priority substances, cadmium, nickel, and lead. So this work is based on MONITOOL results, of course, and has been done in collaboration with my IFREMER and MONITOOL colleagues. So before talking about the use of DGT results in a regulatory context, I would like to speak a few words on the context. According to the WFD, the Water Framework Directive, the chemical status of water body is assessed on the basis of the compliance for each priority substances of measured concentration with EQS, environmental quality standards. The annual average of monthly concentration measured in spot water samples is compared to the AA EQS marine water, that is the annual average EQS. For priority substances, the EQS are defined at a European level. They are derived from ecotoxicological data following a methodology defined in a technical guidance document. In the case of metals, the EQS refers to the dissolved fraction. Dissolved concentration. As you know, DGT results cannot be compared directly to EQS marine water. Thus, there are 2 major differences to consider between DGT and spot water sample. Firstly, results do not represent the same sampling time scale, a time integrated measurement via DGT, representing few days versus an average concentration from spot water sample. Secondly, there is a difference in the fraction analyzed, label fraction in DGT versus dissolved fraction in spot water samples. Different chemical forms are measured depending on the fraction considered. The label fraction is described as being smaller than the dissolved fraction. Thus, comparing DGT result to EQS may not be as protective as comparing a result acquired with filtered water to EQS. So according to the WFD, it is possible to adapt EQS for other taxon or metrics, but in this case, it must be as protective as the EQS defined in marine water. In order to use DGT results for the water body chemical status assessment, 2 options will be described here. In the first option, the principle is to compare DGT result to EQS DGT, which means that we have to adapt the existing EQS marine water into EQS DGT. And in the second option, the principle is to have the possibility to compare the DGT result to existing EQS marine water, which means that we have to predict the concentration of metal in dissolved fraction from DGT results. Both of these options implies to establish for each metal a valid relationship between dissolved concentration measured in spot water samples and the label concentration measured by DGT. In one case, the relation allows to predict the concentration in DGT from the measured concentration in dissolved fraction. And in the other case, the inverse relationship is considered, and it is possible to predict the concentration in dissolved fraction from DGT results. So I'm going to present you the results of these two options. And after that, in order to assess the applicability of proposed EQS DGT, I will show you a simulation of the chemical status assessment based on MONITOOL site. So for each season and for each site and season, wet and dry season, the average of DGT and the average of the concentration measured in spot water sample were calculated. Results for metal showed rather linear relationship between concentration measured in dissolved fraction and in DGT. Thus, the choice has been done to model the relationship with a simple linear model. This linear model is surrounded by its predicted interval in green line. 95% of the DGT result will be between these two lines. The green area, maybe I can show you here, the green area here corresponds to the range of validity of the model. So this process has been run for cadmium, nickel, and lead. You can see on these graphs the results. So what can be noted first is that MONITOOL results for cadmium and nickel are far below the EQS marine water values. Okay, so for cadmium, highest concentration are just above half of the EQS marine water value, and for nickel, results are less than about 1,500 nanogram per liter, while the EQS marine water values is 5 times higher. Concerning lead, only one site presents results above the EQS marine water value for wet and dry season. Thus, even if sampling was carried out in suspected highly contaminated sites like harbors, results are much below the EQS marine water values. So based on this relationship, the determination of the EQS DGT is done in a pragmatic way for cadmium and nickel, as it is outside the range of validity of the model. The predicted EQS DGT number 1 is determined at the value of the linear model regression, and the EQS DGT number 2 is determined at the lowest prediction interval in order to be more protective. So you can see here in the table the proposed EQS DGT number 1 and number 2 for cadmium, nickel, and lead, expressed in microgram per liter as done in the regulation. So this was the first option to adapt existing EQS marine water into EQS DGT. In the second option, the inverse relationship is considered, and it is possible for each metal to predict the concentration in dissolved fraction from DGT results in the range of validity of the model. You can see on this graph the linear model, its predicted interval, its prediction interval, and the range of validity of the model. This range is below the EQS marine water value. So in the last part, a simulation of the chemical status assessment is presented. This is only a simulation, as not all regulatory requirements are met, but the idea is to compare whether the assessment based on DGT results is consistent with the assessment based on spot water sample. Currently, the directive requires to compare the average of monthly concentration measured in spot water sample during 1 year, that is 12 results, to EQS marine water. In MONITOOL project, 2 seasons were considered, wet and dry season. Water spot sampling were carried out during DGT deployment. There were at least 3 samples for coastal sites and 8 for estuarine sites for each season. And so an annual average concentration was calculated for sites with result for with results on both seasons. And this average was compared to EQS marine water. Similarly, the average of DGT result was calculated and was compared to EQS DGT number 1 and number 2. So you can see on these graphs results for cadmium and nickel. The annual average concentration for spot sample, the dissolved fraction, is in green and can be compared to the EQS marine water in green. And the annual average for DGT is in blue and can be compared to the EQS DGT number 1 and number 2, the same way for nickel. So you can see that all the annual average concentration are below the EQS values, and results of these assessments are compliant for cadmium and for nickel. Concerning lead, among the 19 sites for which an annual average can be calculated, there is one mismatching for one site. One site is above the EQS marine water here, and one is above the, for the EQS DGT number 1, one site is above the EQS DGT number 1, but it's not the same site. And considering the EQS DGT number 2, 4 sites are above the EQS DGT number 2 value. So the choice of whether to apply DGT EQS number 1 or number 2 depends on the willingness to be more or less protective. So in conclusion, based on the MONITOOL results, it could be pointed out 3 main points. Firstly, it should be underlined that even targeting highly contaminated sites, results are much lower than EQS marine water. This raises question about the relevance of the EQS marine water value. Maybe an update of those EQS should be done, as the dossier, the fact sheets are quite old, 2005 or 2011, depending on the metal considered. And it would be necessary to include more ecotoxicological results for marine species, and it should be considered the bioavailable fraction in the EQS derivation. Secondly, MONITOOL results demonstrate the possibility of using DGT results in the context of the regulation for chemical status assessment. There are 2 options. Compare DGT results directly to proposed EQS DGT, or predict concentration in dissolved fraction from DGT results before being compared to EQS marine water. So from a technical point of view, both options could be applied. The difference between the 2 options is whether or not it is possible to go beyond the validity range. In the option 2, the validity range of the model are lower than the EQS marine water, but they might be sufficient. This validity range could be compared with the highest annual concentration met in water body under the WFD to assess whether this range is wide enough or not. For regulatory recognition, the second option seems to be easier and quicker, rapid to implement, as it does not seem necessary to include it in the regulation. It would be important for us to have your opinion. Is one of the 2 options preferable and easier to implement? Perhaps you will give your point of view during the breakout sessions. And finally, to go further, we could propose to carry out a chemical assessment process in real conditions as expected by the regulation. A pilot study could be set up. It could be the next step to validate the applicability of DGT results for chemical status assessment, and could provide necessary data to design the strategy to implement DGT in monitoring. I have finished my presentation. Thank you very much for your attention.
Thank you very much, Isabel. And thank you for flagging the types of questions that we can expect in the breakout session, which is I'm very much looking forward to. Leading on exactly from that, I had just for the last section 2 slides provided kindly from Brendan McHugh based on the work of Paul Whitehouse and colleagues to stimulate the thought process further for that breakout session. So if I quickly move to share those. And so this is around where the role of DGTs might be in a tiered system. So as an example would be to consider using validated passive samplers in tier 1. And then if there is, and use those to define where there is a positive detection. If there is, then we would deploy passive samplers, DGTs more widely. And if there are exceedances there, then potentially move to tier 2 and move to tier 3 if there are confirmed exceedances as part of that risk assessment. But the increased sampling would allow us greater confidence as part of that assessment. So in that perspective, we could use DGTs potentially to assess the temporal trends for a defined period of time and to observe what the trends are, whether there is an upward trend or whether even if there is below the threshold value, that we can use the passive samplers and the DGTs to evaluate as part of that broader risk assessment framework, whether we do need to carry out more analysis or at what point we need to move to tier 2. So that is one of, so if I stop share, building on the type of results that Isabel has presented, some of the ways in which we could take this this knowledge and move it forward. So in the next session, so please don't leave for a second, but in the next session, in 10 minutes, when you come back, so please don't leave Zoom. We're about to go for our next coffee break. So even if you go back to GatherTown to catch up with more people or to check out the posters or the videos, please stay logged in here into Zoom. And then when you come back at 12:15, you will be in your breakout room. So our technical colleagues will move everybody to their breakout rooms while you're on coffee. And then when you come back, you'll be in that breakout room, one of the 3 breakout rooms with a specific question, and we're very anxious to hear your voice. You've heard MONITOOL's voices till now. We're very anxious to hear yours in that. So that breakout session will take 30 minutes. And then you will have a 30-minute lunch break. And when you come back from your 30-minute lunch break, you will be back here in this main room. And Miguel and the rapporteurs from the individual breakout sessions will lead the discussion on everything that was discussed in those parallel sessions when we come back. So the last request before you go for coffee and to stretch your legs and to catch up with people would be to please, if you've not already done so, to help us to put everybody in the correct breakout room. If you could make sure that your name on Zoom is the name you've registered with, and you can change your name by going to participants, then clicking on the blue more button that appears beside your name and then choosing to rename. So if you could do that, if you've not got, if you, for example, have the name of your department or your institution instead of your personal name, it would help us to put everybody into the right section. So then with that, I invite everybody, thank everybody this morning for giving all the really interesting results from the MONITOOL project. Like I say, this next section is where we hope to hear your voices. Everybody who's come to join us today, thank you very much. So we now go for coffee for 10 minutes. Please stay logged in here, and when you come back here, you'll be in your breakout session, or your breakout room. Thank you very much.
Hello, Laura.
Hello, Ada.
Thank you everybody for coming back. I hope you had, sorry, turn my video on. I hope you had a nice lunch. It was a very quick lunch and not the nice delicacies we would hope if we were all in Lisbon together for Miguel's plans to have been realized, but unfortunately we're not. But I hope you had nice lunch in any case. And this session is going to be chaired by Miguel. So I'll hand over to Miguel now. Thank you, Miguel.
Okay, I just have, there is a lot of echo. So please, I ask for disconnect your audio systems. Okay.
If you close your Gather 10 tab, Miguel, it should improve.
Yeah.
Everyone else is muted, so it should be all good then.
Okay. I still have an echo. I can turn. Okay, please. Can you turn off your audio? Okay, let's go for the next section. I think there is a lot of us here in the meeting room. So I hope that the breakout sessions were a success. And I will ask, please, for each of rapporteurs to do a short synopsis of each of the breakout session to share with everyone. And then we will see how discussions go through from it. I think, Maria, you are the rapporteur for the first section. Can you please give us a synopsis of the section, please?
Yeah. Hello, Miguel. Hello, everybody. Do you hear me? Yes. I am reported with how. I don't know what is how. Okay. From the questions we have, maybe I can put. I can share all the questions. Where I have. Wait a minute. Do you see my screen? Yes.
Yes,
okay.
Maria.
The questions that we have for discussion was what evidence gaps, like absence of EQSs for process samples, modeling to total equivalence, equal protection. Do you see that prevent your implementing DGTs as a technique for compliance monitoring? So most of the questions we have is related with the EQSs. The lack of EQSs, it seems to be the main problem. There are also some responses on or some comments on biofouling, like what it is. Yeah, here, how big an issue is biofouling or diffusive boundary layer when producing comparable data for multiple sites? This is one of biofouling. Also, we have another one. And also there are worries about how represent DGTs are promising for average annual EQSs, but they are maybe prohibited for assessing maximum annual concentrations EQSs unless you implement an intensive deployment program. Another response was, let's say, the policy change need. The policy change to need, the legislation, yeah. Also, another concern was about the comparability of data. This means making sure that the standard techniques are used and comparable across all users. Yeah, so I think that these are the main ones, the EQSs. Another one was the bioavailability, biofouling. Other one was the comparability. So make sure the standard techniques are used in comparable way. The concern about how to assess with DGTs the maximum allowed concentration. I think this is what I can see from the responses we have. How do you want to add something here? Something that I don't remember or something important? Hello?
Hi, yes, Maria has given a good summary of our discussion. I don't have much to add. Thank you. Yeah, the main problem is EQS. We don't have EQS for passive sampling, so that's preventing the acceptance of passive sampling. I think that's the first step. Of course, the policy change, that's very important too. The technical problem, of course, there's other breakout group. I'm sure there's lots of discussion about the details of the technique, and we have to make sure it's compatible and also the data reliable. But that's, you know, we can, as a scientist, we can solve those problems. But the major key step is to convince the policymaker to accept the EQS for passive sampler, or we, you know, adopt the EQS, the existing EQS, but make the DGT measurement or other passive sampler measurement equivalent to total dissolve. So that's the main message from this breakout group. Thank you.
Okay, thank you, Hao. I see that Cohen raised his hand. We can do it relatively to this section, and we can go further to other section. Cohen, can you add your comment, please?
Thank you, Miguel. Yes, well, I think with regard to EQSs, this is all under the precautionary principle. For example, if you look at EQS for mercury, it is calculated as if all mercury would be present as methyl mercury, which is the most toxic form. And of course, you can take that as a norm for methyl mercury. That is fine. Normally, your ordinary mercury can be higher. And the same you see for arsenic. They all assume that the arsenic is inorganic arsenic. Would that be the case? We would be in big trouble in the marine environment, I suppose. And I think here so as well. For metals, for example, they mostly look at if all metals were dissolved. So you could more or less linearly use these existing EQSs, because this is the truly dissolved or the available fraction. So it's the worst case scenario, as one would say. So I think this is valuable.
Okay, thank you, Cohen. I see no other comments at this stage for session 1. We'll now go to session 2. I think, Philip, can you do a synopsis of session 2, please?
Yes, thank you very much, Miguel. So this was really looking at what steps need to be taken to make passive sampling operationally achievable. So, I mean, first of all, there's still some evidence gaps. So, for example, is labile versus dissolved concentrations in different region, how important is that for different metals? And there's still body of evidence to develop there. And as well, checking the EQSs, the DGT EQSs, whether they're protective enough in labs using marine species, for example. So there's some more evidence gathering, but as well, at the moment, there's a lack of technical guidance document at an EU level, and that would be developed. These need to be developed under the auspices of CIS and drafted by experts in member states. And these include all aspects, basically, of passive sampling or DGT passive sampling, from strategy and guidance to interpretation of the data, and the tiered approach discussed earlier is quite interesting, and the evidence generated by the MONITOOL project is very useful as well in developing these guidance documents, which are quite a lengthy process. As well, we need to consider other uses of DGT, not just compliance monitoring, but trend monitoring. So that's another aspect. And in the wider passive sampler fora, DGT are at a different place than silicon rubber samplers or POSIs, for example. So it's kind of situating DGT within that space, and the IC's Marine Chemistry Working Group is developing a document looking at all of the passive samplers. The Norman Network is developing a position paper, has done quite a lot of work on silicon rubbers, and I understand from the discussion that a position paper is being prepared. So kind of generating a super dossier, kind of working with all those kind of networks, groups to generate a super dossier seems to be a very useful approach. I think that's all I've got at this point. I'm looking at Blanid, whether you've got something to add, whether I've forgotten something.
No, that was a really comprehensive discussion or summary of what was a really useful discussion around how we take what we have done so far and build on it in a way that means it can be operationalized. So no, great job, Philippe.
Thank you. And thank you to all the participants to the session.
Thank you, Philippe. I'd like to promote this discussion, very interesting issues raised by Philippe. If anyone from audience would like to make a comment on that. Otherwise, we can go through a short synopsis of section 3. Irache, are you there?
Yes, Miguel. I'm going to share my screen because we put all the answers, or we group the answers in different groups. So
okay, perfect.
So from the third question, in relation to what are the next steps to ensure the EQS for DGTs be incorporated by end users and national and international monitoring agencies for a more effective water treatment directive monitoring program, we received 18 answers with several likes, and we grouped these 18 answers in 4 main groups. The first group is in relation to the technical issue. The answers were in relation to the different results from the spot sampling and the DGT's results, metal concentration in the framework directives, the accuracy of these EQS values, And some of the answers were in relation to the development of pilot studies to compare these two different technologies and their corresponding EQS. We also received answers in relation to the bioavailability because, in these answers, we include the connection of the DGT to the bioavailability and trying to connect these DGT results to the bioavailable metal concentration. So these pilot studies could increase some of the participants said that there is a need to include or to increase the studies of the EQS DGTs to better validate of their use in the context of the directives. The second group was in relation to the networking, in relation to the promoting the close collaboration between the monitoring agencies in developing a networking and creating a consortium with different water agencies and stakeholders, and to organize the aforementioned pilot studies. The third group was in relation to the dissemination of the advantages of passive sampling, promoting a wider understanding of how these DGTs link to the current chemical assessment and the future impact of introducing the DGTs in the directives. And finally, the last group was in relation to the passive sampling in the context of the directive, in order to promote a fluent link between the regulatory framework, the European regulatory framework, the national laws that it was mentioned in the previous breakout session groups, because we consider that it's important to clarify in which strategy and monitoring, if it's investigative, operative, of the water framework directive, can be included this technique, this passive sampling. And that's all, Miguel.
Okay, thank you, Irache. Can I see any comment from the audience?
Hello.
Well, yes, Joseph, please.
I would like to say here that perhaps we should ask for DGT to be a complementary technique to the dissolved total concentration, not a replacement. Perhaps at least at the beginning, it could be just as a complementary that giving more information. With the two values, you have more information, and perhaps this could be a way of convincing the policymakers to consider this passive sampling. Thank you.
That's a very good, thank you very much. That's a very good comment. In fact, it goes close to some of the comments on the sections that promote side-by-side monitoring and adding at the beginning first information, given information for everyone, and try to show to not only to scientists but also to other stakeholders how might be relevant also the DGTs and how might be used on the future. This also goes in parallel to a bridge that can be made with the passive sampling using for organics, which is more widely accepted or will be more widely accepted on the future, and to create a bridge between the inorganics and the organics may also be a process to stakeholders understand. Any other comments, inputs? Cohen, I see that you raised your hand.
Yes, thank you, Miguel. Just a small comment. What we have from time to time during spot sampling is high values for some compounds, and we more or less think that they are caused by the vessel and by a small mistake during sampling, which is much less prone to be the case with DGT sampling. So this evitate, because then you have your annual average EQS and your MAC EQS, and you can easily have an exceedance of your MAC EQS whilst nothing is actually going on, but you cannot prove it. Because of course, if it would be crystal clear that you had a contamination during your sampling, you would have discarded the sample anyway. But once you analyze it, you have very little reason to neglect the value. And DGT sampling would overcome this because it's much more difficult to contaminate your sample. If you follow the protocols, it's less prone to contamination at least.
Yeah, you are correct, Cohen. That's one point. The other point that I may like to add on this issue is that, for example, in the environment, if you see a punctual contamination that may occur 1 or 2 days, and that if it was the day for your spot sampling, you will get high value contaminated. But if you integrate that on time, it will not be related high value. So in this case, passive sampling will be an advantage for other comparing for the spot sampling. May I ask if there is other additional? And try to see the raised hands here, which is not easy. So at least for the 3 sections, that was very clear that was a lack of EQS for DGTs, and that causes an impact on most of stakeholders, that because they probably don't know how to act at this stage. There is also some technical issues that related, and biofouling was one of them, cited, that may be needed to further research, although a lot of them has been done. And the link between policies and established data that we may get, it's also relevant and has been raised out. The technical guidance for PCT users, it will be for sure fantastic tool, as raised on section 2, how to use it, when to use it, how to link it with directives, that may be also a relevant point. One of the things that was also raised out by the 3 rapporteurs was to promote the close collaborations with the monitoring agencies and the research or the universities, and create consortiums that at first stage may improve the use of DGTs and see their usefulness. I have a raised hand. Sorry if I didn't see you. Mate, can you please?
Hello, good afternoon, everyone. Well, my name is Maiti, and I work in editorial, and I work in surveillance. So I think I'm going to be one of those end user of DGTs, and I've been listening to all of you, and this is an amazing tool, and I really thank you for this amazing research. But well, I have 2 questions. The first one is, of course, we use this kind of regulated surveillance plan based on the national laws, and of course we use this EQS levels. So we need this kind of match between the EQS for DGTs and the EQS for spot measurements. So that's our main concern. And the second one is if you have tried to use these DGTs in residual effluents, because in these surveillance plans, we have to measure the effluents, the water masses and the sediments, organisms. But I don't know if you have tried to use this kind of measurements of DGTs in the effluents, in the residual waters. I don't know if I don't know if maybe with the mask is I don't know if you have understand me or
yes,
not.
yes, we have understood you. Thank you so much.
Thank you.
For the project, I don't know if Blanade wants to make a comment on questions from Mayte.
Except to say that the next session that we're going to after this, it is specifically addressing everything that you've raised. So I would love you to come to participate in the next session with us, because exactly what you were talking about is one of the things that has been raised to us that we want to follow up on. Absolutely.
Great, thank you.
Sorry, Blennet.
Yes.
Anyway, Maite, later maybe we can speak, but yeah, we have tried inside of the MONITOOL project in Gran Canaria with different type of effluents, so we can speak later about it. Okay.
Great. Thank you, Vanessa.
Okay, perfect. If there is no further comments, and we may enter on the next section, issues, I suggest to the following, I think it's Irache for dissemination activities, isn't it?
I think it's Vanessa and Marta.
It's Vanessa. Yeah, Marta and Vanessa, pardon. Marta or Vanessa, can you please take the floor?
Yeah, can you hear me, please?
Yes.
Yes.
Okay. Ready. Full screen. Okay, thank you very much. So we have prepared a short presentation to show the main outputs of MONITOOL project after 4 years of work. I'm the one speaking in front of the camera, but behind the work I'm presenting today, there are more people. Let me at least for 3 seconds show all the colleagues who have been involved in this communication work package for 4 years. And this time, as always, I have Vanessa by my side, far, but by my side. So, since, sorry, no, not this one, sorry. Yeah, since the beginning of the project, we have some objectives, and one was to assure that all outputs of the project will be available for all the target audience. And if we did that job well, now each one of you are one of our target audience. So all of the outputs of the MONITOOL project are on its website and therefore open to anyone with a computer and a decent internet connection. You have the MONITOOL website, you can see in the screen now, and it includes the classic or standard sections of all of the project's website. But for what we are pursuing today, the key sections to visit are the work packages section, the publications, and the multimedia. So, in the work package section, all of the information corresponding to these work packages is included individually. You can see that in the case of the technical work packages, which are 4, 5, and 6, the final deliverables will be available as soon as they are finished. By the end of June, when the project finishes, each in these work packages, you will find all these deliverables. And these include a detailed description of all the work, methodology, results, conclusions, everything that has been done in the course of the project. In the publication section and within the scientific dissemination tab, the following publications can be found. Some of them they have been said. Our partners have been spoken about them, but as a compilation, we have an article recently published in the Stotten Journal with the data and conclusion that have already been mentioned by Germán earlier in this conference. Another article that has recently also been submitted with the methodology developed, and the one used by the Interreg Consortium. Also, in the framework of the project, there is a Master of Science thesis written and defended by Martin Nolan from DCU, one of our partners, and a chapter in a book, the one you can see there, that was published last year. Well, this slide summarizes the contributions made during the attendance of the partners to congresses, seminars, and workshops during the lifetime of the project, and which are also included as outputs on the website. Everything is there. Some of them you have already seen in the Gather Town if you have been having a tour inside it. And they have been in total 6 oral presentations, 5 posters, and 6 conference abstracts. We are also close to finish a good practice guide. T has also, from Cephas, she has also mentioned it, a guide for sampling of metals in transitional and coastal waters by DGT technique. This guide is intended to provide practical and detailed information on the use of these devices and the essential step for the whole procedure. Now, what you can see on the website, it's some kind of appetizer where you can see the contents, but it will be available completely in 2 weeks. In the multimedia section, there are also short videos, all of them very simple and very explanatory. Among them, and to highlight some of them, you've got the MONITOOL project overview. This video summarizes the entire project in 5 minutes with all the results and everything. That's the new version available. I think that it's worth seeing it because it's quite complete and gives you an overview of all the project. And there is a second block of several videos made by the colleagues of IFREMER about how to use the DGTs. And it's very interesting and a visual complement to the guide. And finally, and returning to the initial objective of assuring that its outputs are available and used by the target key audience, the consortium has discussed about creating a MONITOOL collection on Rio Journal as a part of the capitalization work package. For those of you who don't know, Rio Journal is a new platform that offers flexible publishing services. It publishes all outputs of the research cycle, including everything: project proposals, data, methods, workflows, software projects, reports, and everything together on a single collaborative platform. As they provide different routes to compose a project collection, we are still, the MONITOOL partners, we still have to decide how to publish our research outputs. But we will tell you as soon as it's ready. And that's all. Thank you very much.
Thank you, Vanessa, for the resume. Any other comments? Blanade, do you want to add any information?
No, except I know we were supposed to finish in 8 minutes, and we will run over by a small few, but for the next 2 sessions that Natalia is chairing, but I'm giving presentations, I will speak quickly. So if people could wait a few more minutes, that would be perfect.
Okay, perfect. So with no further delays, I will pass to Marco, who is chairing the next section.
Hi, Miguel. Oh, yeah. Hi, Miguel. Marco won't be able to moderate this session, so I will do it on behalf of him. And now we are going to start with the last session of today. And this is going to deal with the next steps of that should be carried out, or what is going to happen beyond the MONITOOL project. So now I'm giving the word to Blanet to start with the pilot monitoring assessment.
Brilliant. Thank you, Natalia. And so this question around the pilot monitoring assessment comes from feedback from the questionnaire that stakeholders filled before this conference started. And so the concept is that we will pilot with national water agencies deployment of DGTs alongside the traditional methods that those agencies are currently using to assess the ease of use from the end user perspective, the feasibility of incorporating passive samplers into the monitoring strategies, and the potential benefits for stakeholders and end users of incorporating them into their strategies. So it is really working. Marta flagged that we had started to do this in MONITOOL to work with end users, so it is really expanding on that work in great detail. And from that perspective, while it will be the monitoring agencies who have requested that we consider developing such a pilot, we within MONITOOL are very happy to support the assessment by participating as an expert group with the expertise we've developed to complement the assessment and to include all our results, the EQS values, the formulas within the pilot study to help it realize its goals. So the decisions around it are, and they're not for answer right now, don't worry, nobody to be under pressure, but they're around what national bodies would like to be involved. So if you think you would like to be involved, then to consider what specific case studies might you like to include and what type of pilot assessment. So in terms of like that annual surveillance monitoring or operative or something from an investigative perspective, where particularly looking at chronic contaminated specific sites. So these are all decisions to ask today. But if you would like to be involved, please, we have an email address for the project. So to please, using pilot monitoring assessment in the subject line, to email us at this address if you would like to be involved in an assessment like this, so that then we can realize that the request that came in from stakeholders to maybe to look to see if we could set up a pilot monitoring assessment like this. So that is my whistle-stop tour, Natalia, through the pilot monitoring assessment with the invitation, if you would like to be involved, to contact us.
Yeah, thank you very much, Blanet. Yeah, and now I don't know if Fiona or you are going to finish with this session where the way forward will be presented in terms of the funding and so on.
So that's me again. You have to listen to me for a little bit longer. So I have one last presentation here about this. So this is around the future funding. So this is while it's wonderful to be able to present everything we've done in MONITOOL so far, we are very conscious that we don't want MONITOOL to be the end, and we want to continue to build and develop on our research. So we had started to discuss in Austria around given how widespread MONITOOL is, and that we could become an umbrella network because so many people who are involved in DGT research is either involved in MONITOOL or has collaborations with colleagues in MONITOOL, so that together we can bring all the interested parties together to explore potential further research areas. And there are 5 potential areas that I'm quickly going to talk through today. The first builds very strongly from the breakout sessions and trying to build this pathway to be able to operationalize passive samplers, but also looking at passive samplers for multiple other types of contaminants, and also to consider it from building on strongly what Irachi was talking around passive samplings with biomonitoring, and then potential next steps on a cost action that we'd recently submitted as well. So if I talk through each of these 5 very quickly. So the first is building strongly, certainly from what myself and Philippe had talked about, and I think what was discussed more broadly then in the session with Miguel, is very strongly from multiple stakeholders, it's becoming clear that we need to identify what the pathway is to allow passive samplers to be accepted within compliance monitoring strategies. And so the concept here is to sit down and to look at that pathway, to see what is required, what gaps exist, and then to come up with ways to try to fill those gaps. So that's considering things around the technical guidance, the QA and the proficiency studies, that will allow us to demonstrate, as we've done with the metals in MONITOOL, equivalency to existing methods. So this proposal is around developing a pathway with discrete steps so that we can demonstrate to legislators and Europe, more than likely in collaboration with networks like Norman, how we can consider passive samplers, not just DGTs, within compliance monitoring strategies. The second concept, it uses a similar strategy to what we've used so successfully in MONITOOL, to use common passive samplers within a large European consortium for priority substances that are difficult to detect, particularly looking around the contaminants of emerging concern, things like the PFAS that are very hard to analyze. So looking at the second concept is around then the passive samplers for organic compounds. The third, again, uses the same strategy as MONITOOL, where we use a common device. We'll be suggesting DGTs where we have the expertise. Again, across Europe, looking at rare earth elements, and PGEs, again, in the transitional and coastal waters where we are building expertise in that space. The next is around, again, using a similar strategy to MONITOOL, evaluating using DGTs to replace mussels in different regions and seeing if it's possible to adapt the EQS and biota for DGTs. And as then the last is around the passive samplers for environmental assessments, again in port water, so using a similar strategy to MONITOOL to evaluate the chemical status of heavily modified waters and see, do we need to adapt EQS for this? And then being able to evaluate, which I guess gets to a site-specific question that we were asked in the breakout question 2, whether we can apply DGTs to evaluate for particular specific sites. And then the last question was around, we have been developing a cost action submission to called Metal Marine to develop EQS for metals determination in a monitoring program, which would again develop SOPs for best practice to use DGTs and encourage the use of the SOPs in a way that would be within monitoring programs and would very closely explore the relationship between bioavailable metals from ecotox studies with DGT labile metals, and then engage strongly with policymakers. The last time we scored 46 out of 50, but weren't funded, unfortunately, and there's another submission opportunity coming up. So the question was if anybody wanted to pick this up again to see if it was something that we wanted to explore. But that is, again, 5 potential areas for where further research could occur. And again, we would invite people. I realize we're running out of time today to discuss it here and now, but again, please send the email to follow up if there's anything that we talked about here today that you're interested in progressing, so that everything we have built and learned and developed in MONITOOL can reach bigger and broader and continue into the future. So I will stop talking there, Natalia, and hand back to you.
Okay, thank you, Blanette, for explaining so clearly what is the future of MONITOOL or what are the new steps that we will attempt. And I don't know, I didn't see any question for you in the chat, so I don't know if you want to finish or do some remarks of all the conference. So I can give you the word again if you want.
Thank you very much. I guess that the only thing that remains to say on behalf of the entire of the MONITOOL team is to thank you very much for attending today. Because a huge component of MONITOOL is to disseminate our findings. We have carried out a huge amount of analysis. We have spent years working on the interpretation, the statistical analysis, and we're very excited to share it with you today. So we're very grateful for you for coming along, for attending all the sessions. It was a really intense day, but thank you very, very much. And we look forward to continuing to engage with you going forward, but I'm going to pass back to Natalia now.
Yes, sorry, I just saw the question posted by Olivier, who is saying that if it would be possible to upload all the presentations onto the MONITOOL portal. As it had explained before, we are going to publish the final report of the conference. And of course, we will try make available the presentations given today. So we will send it to you via email or just directly upload them in the MONITOOL webpage. So, yeah, Planet, sorry for the interaction. You can continue if you want. Thank you.
No problem at all. And then finally, just to say, everything is in the GatherTown space still. The posters, all the videos, everything that Marta talked about. So if you have any time after this, please go back to GatherTown, have a look, have a virtual beer if you can't have a real one, unfortunately. And thank you most sincerely again to everybody for our stakeholder conference. We really appreciate it.